All right, to celebrate CS Ed Week, I'm going to be taking you through a pretty cool demonstration of how to create a circle out of triangles. So with this, we're going to be using CMU CS Academy's sandbox feature and some pretty cool trig concepts. So the first thing you're going to need to know while going into this demonstration is a little bit of trig, which basically deals with the relationship between angles and side lengths in right triangles. So as you can see here, we've got our right triangle. It's got an adjacent, an opposite, and a hypotenuse side. And there's just a quick summary of some trig functions. Sine theta equals opposite over hypotenuse, cosine theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent, but we're not going to use tan in this demonstration today. So with that prerequisite knowledge out of the way, let's dive into how to actually derive an x and y coordinate for any point on a circle using right triangles. Okay, so the first step in deriving an x coordinate is looking at the unit circle. So if you see here on the circle on the screen, we want to derive the x coordinate of this point P. So the way we're going to be doing that is by using cosine. So as we can recall from the previous slide, we know cosine theta equals the adjacent length over the hypotenuse length. Now, just by observation, we can notice that the hypotenuse is actually always going to be the radius of the circle. So with that fact in mind, we can just replace the hypotenuse with the radius, do a little bit of manipulation of the equation, and get that the adjacent length is the radius times cosine theta. And if we look at the diagram, we can see that to get the x coordinate, we do want to look at that adjacent side length. Now, there's one little adjustment that we're going to have to make to adapt it to the sandbox, and that is to add 200 to this value. Why is that? That's because the value here could be negative, as we can see in this diagram, that there is a maximum of negative or a minimum of -1. But as you may know, the sandbox starts at the top left corner with 0, 0, and only has positive values. So to basically simulate that effect, we're going to add 200 to make the 0, 0 center basically at 200, 200. Okay, so with that in mind, we're now going to derive our y coordinate in a very similar manner. So this time, if we just look at the screen, we can see, okay, to get the y value for the point P, we need to look at sine theta. So we can remember from the trig diagram that sine theta equals the opposite length divided by the hypotenuse length. And again, the same fact in mind, the hypotenuse is always going to be the radius of the circle. Do a little substitution, a little manipulation of the equation, and we get radius times sine theta equals the opposite length. And when we look at this diagram, we see that this opposite length is what we need to get that y coordinate. We add 200 to adjust it just like for the x coordinate, and there we go. So now with this knowledge, we can basically define the x and y coordinate for any point on a circle. So that's going to be pretty handy once we start to actually create the triangles that are within the circle. Okay, great. So now that we know how to find points on a circle, we want to actually use triangles to make a circle. Now, how can we simulate a circle using triangles? We're basically just going to create a lot of triangles centered at the middle of the circle, so as you can see here on the diagram. Okay, so let's put that knowledge to use. So we've been talking a lot about cosine theta and sine theta without actually defining what our theta is going to be. So now we're going to look into that. So as you can see on this diagram, each of our triangles within the circle can be broken down into two right triangles. For example, this red triangle and this blue triangle. So each of our triangles is going to be like the green one, like a slice of a pizza, and we can define each of our 3 points based off of this diagram. So we know one of the points is always going to be 200, 200, or the center of the circle. We can get one of the points by doing the x and y coordinate derivation on the red triangle, and the X and Y coordinate on the blue triangle for the third point. So from that standpoint, we have basically those 3 points defined. But what about the theta? So as you can see here, the theta for the red triangle is going to be different than the theta for the blue triangle. So that's where we're going to use an arbitrary variable that we came up with, for example, point dis. So point dis is basically going to tell us what the incrementing value is between each of our little right triangles that create our slice of the pie. So point dis can be very small, it can be very large. If it's a small point dis value, that means that the triangles are going to be very narrow. We're going to need many more triangles, but it will also resemble more of a smooth circle. And if we have a very high point dis value, it's going to be a little more angular. Okay, so basically the whole point of that was to say that the theta for our 2 different calculations are going to be different, and they're going to be incremented by this point dis value. Okay, and I guess another point just to keep in mind is that the starting and ending are going to be continuous. So the ending for this triangle will be the start of the next triangle, and so on and so forth, so we get a fully well-rounded circle. Okay, so with that being said, let's go into a quick demonstration. God, crop this. Okay, so we are back. Let's go into how we can actually create this on our sandbox. So the first thing you're going to want to do is import the math library. So that'll give us access to a lot of really important functions. For example, any trig functions are going to be within that math library. It'll also give us access to radians, which we're going to implement as well. So the first thing we're going to do is actually define a function. We're going to call it circle try. It's going to take in 2 arguments, the radius of our circle and the point dis, like I'd mentioned before. Okay, great. So how do we actually want to create this triangle? So a triangle is basically just a polygon with 3 points. So we can say polygon. Now the first point is really easy. That's going to be consistent across all of our triangles, and that's the center, 200, 200. To get our first point, we're going to use the cosine and sine that we talked about in the slides. So we can simply do 200 plus math.cosine angle times radius. So that's that derivation we did. And the same thing for sine. Okay, so there we go. We've got our first 2 points done. So now for the last 2 points, last 1 point, excuse me, we're going to increment it by point dis. So what we're going to do is we're going to say 200 plus math.cosine angle plus point dis. Oh no, I have to start this over. Okay, so now we're actually going to create our triangle. Okay, so now let's actually learn how we can use everything that we've learned to actually make a circle out of triangles in the sandbox. So the first thing you're going to want to do is import the math library. So the math library will give us access to a lot of important functions, specifically the trig ones that are important, as well as radians. Okay, so now we're going to define a function. Let's call it circle try. It's going to take in 2 arguments, radius and point dis, like we talked about. Okay, so we know that we have to make many, many triangles. So the way to best do that is to use a for loop. So let's do for angle in range. We know it's going to be from 0 to 360, so a full around the circle, and it's going to be incremented by point dis. Amazing. Okay, so now for each segment in this for loop, we're going to create a triangle. So what is a triangle? a polygon with just 3 points, so we'll call polygon. The first point of the triangle is super easy. It's going to be consistent for all triangles. That is 200, 200. And now we're just going to use what we worked on in the slides, deriving the x and y coordinates. So 200 plus math dot cosine, math dot radians, angle times radius, and then 200 plus math dot sine, math dot radians, angle times radius. So that will give us our second point. And now to do our third point, we just have to increment the angle by point dis. So we'll do 200 plus math dot radians, angle plus point dis times radius. Oops, I forgot to put the math dot cosine. And then 200 plus math dot sine, math dot radians, angle plus point dis times radius. Okay, let's do something fun. Let's put fill to equal hot pink. Okay, so that is basically the structure of our code, and now we just need to call it. So let's call circle try. Let's make a 200 radius circle, and we're going to do the point dis as 5. It can go as low as 1, it can go as high as 6. So let's take a look. There we go. We've got a hot pink circle made out of tiny, tiny triangles. So as you can see here, if we increase that, we'll get a slightly more angular, there we go, a more angular circle. But if you use a really small point dis, yeah, we'll get a pretty smooth circle. So that's how you can create a circle out of triangles on the sandbox.